Recursive rule to explicit rule. Well, how do you write an explicit rule if you're given the recursive rule? Now, remember that a recursive rule tells you how to go forward or backward if you know one term, one of the terms in a sequence of number. For example, if the recursive rule is a sub n is equal to a sub n minus 1, the term, okay, the number before, in order to get the number after that, you're going to have to add 5. Okay, that's what the recursive rule is telling you. Now, if you know that the first term, or a sub 1, is equal to 6, you can list all the other numbers after 6. So let's do that. Okay, let's number the terms. Okay, it's going to be first. Okay, let me see. Let me write it down. First, second, third, fourth, fifth terms. Okay, you know that the first term is 6. So let's see. That's it's gonna be 6. That's first term. The second term is, in order to get the second term, you have to add 5. Okay, that's what this plus 5 is telling you. This is gonna be 11, and then after 11, you're going to have to add 5. It's going to be 11 plus 5 is 16. After 16, you're going to have to add 5. It's going to be 21. After 21, you're going to have to add 5. It's going to be 26. As you go forward, you continue adding 5. All right? So that's how you use the recursive rule. Now the question is, what is an explicit rule? Well, an explicit rule is not just a simple instruction on how to go forward or backward. An explicit rule is a formula so that you can find, okay, if you know n, or the term placement, okay, whether it is the first, second, third, fourth, fifth, okay, you can tell the term, the number a sub n, okay, what number is placed in the order that is given by n. For example, you say, what's the 100th number in this sequence? And that's what we mean by explicit rule. So this sequence of number is described by the explicit rule a sub n is equal to a sub n minus 1 plus 5, when the first term is equal to 6. Now, you can find the explicit rule, or what formula actually describes this pattern, so that if you're given n, you can find a sub n without adding 5 repeatedly. All right, so let's do that. So we start with 6. That's gonna be our first term. Okay, the second term is 6 plus 5. The third term is going to be 6 plus 5 plus 5. The fourth term is going to be 6 plus 5 plus 5 plus 5, because we continue, we are just repeatedly adding 5. Now, let us write addition as a shorthand, that is multiplication. So we can rewrite these terms as you start with 6, and then you have to start with 6 times 5, and then 5 times 1, I mean 6 times 5 times 1, and then you have 6 times 5 times 2, and then you have 6 times 5 times, 6 plus, not 6 plus, okay, 6 plus 5 times 3. Now notice that the number we're multiplying by here, we're multiplying 5 by, here is, okay, here is 1, this is 2, this is 2, that's 3, this is 3, that is 4. All right, so take notice of that. Now, so what about 6? This one here, we can write this as 6 plus 5 times 0. Notice that we're adding 5, but when we write it using shorthand multiplication, we're actually multiplying 5 beginning from 6. Okay, beginning from 6. Everything begins from 6. And then we're adding 5 times a number, 5 times a number, 5 times a number, 5 times a number. But the number that we're multiplying by is always less than n, less than these numbers right there. Okay, these are n. That's n. All right, so that if we go down to any number n, we can write, okay, we can write we can find our number as just 6, the same number that we start with, plus 5, the same number that we're adding by repeatedly, times, okay, we'll just follow the pattern. It's going to be, if n is equal to 4, we multiply it by 3. If n is equal to 3, we multiply it by 2. By 2, by 1. It's always 1 less, isn't it? Okay, so it's going to be 6 plus 5 times n minus 1. So that's what we mean by an explicit rule. Our explicit rule for this is going to be a sub n, the nth term, is equal to, well, we start with 6. We're adding 5. How many 5s are we adding? Okay, we're adding 5 times n minus 1. All right, so we have our recursive rule, recursive formula. We have the explicit rule or explicit formula. We don't have to add 5 recursively or again and again and again and again. We can just plug it in this formula, so that if we want to find what is a of 11, okay, a of 11 is going to be equal to 6 plus 5 times, well, n is equal to 11, so it's going to be 11 minus 1. So we can just evaluate this. 6 plus 5 times, well, 11 minus 1 is 10. So it's going to be 6 plus 5 times 10 is 50, plus 6 is going to be 56. All right. So this is an example of how you write the explicit rule from a recursive rule. Okay, it's just a little bit complicated because I'm showing you everything, but once you get the hang of it, actually you can almost do it in your head. All right. Let's take another example of writing the explicit rule from a recursive rule. This time it will involve multiplication. So the recursive rule is a sub n is equal to 3 times a sub n minus 1. The first term is 5. So when n is 1, a sub n is 5. Okay? When n is 1, a sub n is 5. And then we're being told to get the next term, we just multiply by 3. So it's going to be 5 times 3. This next term, the third term, is going to be 5 times 3, the previous term, times 3. And then the fourth term is going to be 5 times 3 times 3, the previous term, times 3 again. And then the fifth term is 5 times 3 times 3 times 3, the previous term, okay, times 3 again. All right, so now notice that, well, we cannot continue listing down the 3s, so there must be a shorter way to do this, and there is. All right, 5 times 3 can be rewritten as, well, this 5 times 3. But 5 times 3 times 3 is 5 times 3 to the second power. Instead of writing this, it's going to be 5, this one here, okay, 5 times 3 to the third power. Third power, right? Okay, yes, to the third power. and then instead of writing 4 3's right there, just write it as 5 times 3 to the 4th power. Now, I want you to pay attention to n and the exponent. Okay, the exponent of 3, that's 1 over there. Should be 1. Okay, 1. And of course, okay, 5 is gonna be 5 times 3 to the 0. There's a pattern there. 0, 1, 2, 3, 4. All right, pay attention to the exponent. When n is equal to 2, the exponent is 1. When n is equal to 3, the exponent is 2. When n is equal to 4, the exponent is 3. When n is equal to 5, the exponent is 4. And when n is equal to 1, the exponent is 0. Notice that those exponents are just 1 less than n. Okay, so that, okay, if you're asked to write, okay, what if, okay, we continue counting down to n. Okay, so our term to get the nth number is just gonna be 5 times 3, what we always do, 5 times 3, but then the exponent is gonna be 1 less than n, or just n minus 1. There you go. Okay, so if we know a sub n, if you know n, a sub n is equal to 5 times 3 raised to the n minus 1. All right, so basically this just becomes the exponent of what we're multiplying by. Okay, and 5 right here, just the first term. Okay, so that's an explicit rule that involves multiplication instead of just addition.